Let's kick off a new series of tutorials with this sparkling circle pit, rendering as many particles your GPU allows with the instancing technique in the integrated 3D engine Stride. Also, we will explore how to use texture feedback to apply this blur effect over time on the rendering, and as a bonus, by the end of this video you will also know how to use so-called channels in VL to create a custom user interface and set several properties in the artwork like the speed of the animation, the area in which the particles fly around, as well as their color. We start by creating a scene window and the root scene node, for which we need to set a reference to the pack VL Stride. The basic primitive for our particle system will be a sphere, and as we don't need any shadows or lighting in the final rendering, we can simply use the color material on the primitive and expose the color input. Let's also decrease the tessellation for the sphere to save some performance, as we don't need that much geometric information, and also scale it way down so we only have this tiny single particle in the middle of the screen. In order to see more digits in the IO box, we can set a higher precision for it in the configuration menu. We could now put this entity into a loop and draw it multiple times, but instead we'll be using a technique called instancing, which allows to draw a much larger amount of particles at a much higher performance. There are different ways of applying instancing, and one is by using the instancing spread component node. Entities accept a range of components as a spread. In this case, we only have one component and therefore use a from value node to create a spread that consists of only one single component. Afterwards, we can generate a circle spread of 2D positions, turn these into 3D vectors with a z value of 0, and send the vector into the translation of the instances. And now you can pull up the count input of the circle spread to create more of these particles along the outline of a circle. To make the particles animate around their initial point in 3D space, we can use the Wanderer 3D node and send the position into the center pin, but we will need to make a few adjustments here. First of all, the area in which the particles can fly around is way too big. Also, the speed should be very low, and we have to pick wrap as a range mode, so when the particles reach the outer bounds of the area, they appear again on the other side. And because we later will control how much they are offsetting from the initial position, we need to use a lerp node to smoothly fade between the static position of the particle and the animated one. If the scalar is set to 0, we see the particle at its original position, and the closer this value is set to 1, the more we fade to the animated value generated by the Wanderer. As the next step, we want to apply texture effects to the final rendering, and in order to do this, we're going to use the custom post effects region and connect it to the scene window. What is exciting about this region is that we can easily retrieve the current rendering by calling the color buffer operation, send it back via the output of the region, and now insert texture effects nodes, for which we need to reference the package VL Stride texture effects. Afterwards, all the nodes in this nugget appear in the category Stride, Textures, Filters, as well as in Mixers, and you're welcome to play around with these. In our case, we will use a technique called texture feedback. Feedback always requires some other node that mixes the previous frames with the current one, so we have to throw in a blend node from the mixer category and send the output of it both into the output of the region as well as the right input of the feedback node. In fact, the feedback will create a copy of the current frame and deliver it to the next one, so we can mix these two textures together. In our case, we also need to set the blend operation to lighten, and the closer we now set the fader input to the value 0.5, the stronger the feedback effect is applied to the texture. What is exciting about feedback is that we can now apply any kind of texture effect to its output, and over time it will then be gradually applied to the final rendering the higher the value of the fader input is set to. For example, we can now insert a blur node and let the trails fade out the longer they are drawn, and the more we fade over to the feedback texture, the stronger this effect will get. This is now also a good opportunity to increase the count of the particles as high as your GPU allows. You can always hit F2 in the scene window to see the current frame rate of your rendering and show as many particles until your frame rate starts to drop below 60 FPS. Finally, we also want to make the structure continuously rotate around its center, so let's create a 3D rotate, which we will use in combination with another wanderer. Let's do a few adjustments here. For example, increase the smoothing amount for the animation and set the range mode to wrap, so that the animation is a continuous movement and not jumping between the values on its edges. Also, we want to make sure that the speed of the individual particles is exactly half the speed of the rotation. Like this, we're basically done with the rendering, and just by playing around with these few parameters exposed in the patch, for example the speed of the rotation, the lerp amount, or the strength of the blur, you can now create different interesting effects. And before we are going to proceed, we will do some patch housekeeping and we'll put our rotating particles into a new node called CirclePit. Simply type that name into the node browser, click Node, cut everything above the root scene, paste it inside of the node, create the output and input pins and name them properly. Afterwards, you can go back to your main patch, connect its output to the root scene, and expose the input pins for speed, chaos, and color. As a final touch, I also want to guide you through creating a user interface to control these three exposed values of our CirclePit node using the ImGUI library that ships with VVVV. In order to use its nodes, we have to set a reference to the package VL ImGUI Stride. Afterwards, the entry point into building an interface is the region called ImGUI, which we can place from the node browser. The region has a renderer output at the bottom, which we need to connect to a render entity, set the render stage to after scenes so the interface is drawn after the feedback pipeline, and pipe it into the root scene. In our case, we're going to use ImGUI widgets to control the speed and chaos inputs. So we will now create two slider floats, chain them into each other to define in which order they appear on the scene, and also give them labels calling them speed and chaos. You can see that these two sliders appear now in the rendering window, already interactive and ready to be manipulated using the mouse. To finally link the widget to the value we want to control, we need to use a channel from the reactive category. It has two outputs, of which we connect the channel output to the widget and the value output to the value that we want to connect. You can now drag the slider to set the lerp value from the window instead of the patch. To also control the speed, we have to create another channel and link it to the other slider. In this case, you might want to check the min and max values of the slider, as we don't want the speed to get too high, so expose the two I/O boxes and set them to something meaningful. Besides sliders, we can choose from a great amount of different user interface widgets, as you can see in the category ImGUI widgets, for example buttons, checkboxes, menus, or selectables. Let's also add another widget called Color Edit after both sliders and connect this via a third channel to the input of the color material. Afterwards, you can then easily open a color picker and use it to control the colors of the particles. And as a final touch, we're going to implement a little mechanism with which you can toggle the visibility of the ImGUI widgets by putting everything inside of the region into another region called window. And don't forget to press space to make sure that the nodes snap into this region. You can now also drag the interface around, scale it and collapse it by clicking on the arrow in the headline. And if you use the isMouse double-click node in combination with the toggle node, you can make the UI also appear and disappear every time you double-click into the window. That's it for this tutorial. Have fun tweaking more of its parameters and exploring all the different techniques introduced in this video. Let us know in the comments if you have further questions, and other than that, happy patching!